So, title of my talk has two words. I think I've reviewed my resume, and I think this is the shortest title I've ever had. So I have to make it a little bit longer. So what I did is I put a question mark at the end of this. And the reason I did so is that indeed the word global or global water is not that dirty word. And we're going to be talking at great length about issues of water, but in particular issues about a global system of water. And even though we're very comfortable doing so at the moment, I'm not sure that that always was the case, and I'd like to just review some of the thinking that we had as we convened the Global Water System Project 10 years ago. And in some sense, this particular conference is a celebration of that first decade of Global Water System Project research. If you know the history of our project, you'll know that we were convened in year 2004, and we posed a set of provocative statements and provocative questions. Our central tenet, or our central hypothesis, as it were, our kind of call to arms, was a statement that we debated at great length, but I think we settled on, I would say, quite correctly. First of all, and I cannot imagine a better set of introductions to this talk than my previous speakers. You all hit on the very issues I'm going to try to highlight here, and you've done some of the heavy lifting for me, so thanks a lot for doing so. But you'll notice that the first word in this organizing principle is the word humans. Humans are changing what? They're changing a global water system, and they're doing so in a globally substantial way. So we introduce this notion that there's indeed a global water system. We go even further than that. We say that humanity is really now calling many of the shots within that system in a globally substantial way. And again, my prior discussants have already laid that idea onto this crowd. There's a little part of this sentence, which is actually the biggest part of the sentence at the end. It says, without adequate knowledge of the system, and thus its response to change. So at the time, and I don't think we've solved all the problems, as Joe Alcamo has mentioned, we do recognize and accept the fact that humans are central to the behavior of the system. But I think where we lack the insight is creating systems of knowledge that we can easily convey to the policymakers to prevent the long list of problems that we've had in the past. Okay, let's talk a little bit about my entry into the world of Engram. So in the last 10 years, Google has been very kind to us in providing us all sorts of very useful and productive information sets. I like to tell the story back in 1997 when we developed the world's first global reservoir database. I had to literally paste maps, operational navigation chart maps on the walls of my kitchen and transcribe where the reservoirs were. And we did this by hand, and it was extremely time-consuming. The grand data set that was mentioned by Anik was a major step forward. It was a major step forward because of Google Earth, where we could literally within minutes, if not seconds, identify a particular reservoir and put it on the map and put it in as part of the database. It used to take hours to do this a mere 10 to 15 years ago. Anyway, I did play with something called Engram, which is a computational linguistics tool that Google makes available to its users. And do I have a laser pointer? Is there a, okay, let me see if I can get my pointer. So you can pair up these words, and you can put it into Engram, and you could ask how these phrases are trending. So what I did is a set of somewhat naive, but I think pretty straightforward calculation requests of the system. I put together local water, and I put together water resources, and I let it rip. And what it did is it looked through the corpus of English language books. So it's not the peer-reviewed literature, but it's a substantial body of knowledge that it went through, and it got the probabilities of putting those two words together. And I think you'll agree that when you put local water and water resources together, they're on the rise. We have a century of books that we're looking at from 1900 to 2008. So local water and water resources are going up, not particularly dramatically. But if we do the same for global water and global water resources, look what happens. We see that there's a a birth of the concept mid-century, and quite literally an exponential rise in at least the mention, if not the acceptance of the term. And it turns out this ends in 2008, so I'm not going to say that the Global Water System Project, which was convened in 2004, really drove this. But what I will say is we came at the right time. We came at a time when the concept of thinking globally and thinking globally about water was ripe and ripe for the taking. And hopefully you will agree that we made some important steps forward in this last decade. We do talk about global water, and we live and work on a blue planet, and you saw this absolutely spectacular 3-minute video that I think, if nothing else, you know we live on a wet world. We live on a blue planet, but I'd like to, at least in relative terms, talk about the water availability that we have to contend with, its problems, and we have to manage better, and we have to be good stewards of. And I'm from New York City, and whenever I have to do this, I do what any kid in the elementary schools of New York, Joe, I'm sure you did this. Michelle Maybeck, who's in the audience, no insult, I'm sorry I didn't use the Eiffel Tower. But this is the way we look at the world in New York City when we have to measure something. And so if you assume that the Empire State Building, I'm sorry that doesn't show up, shall we turn the lights off? Or could we? I think it might show up better. We live on a blue planet, and all the water on the planet is depicted by the height of that Empire State Building. It's 100 stories tall, so if you like to convert to percentages, you have 1% equals 1 floor. And that's what we have as our blue planet water system. I really apologize, this isn't showing up. But anyway, the next little press of the button has indicated all of the fresh water on Earth. So compared to the entire height of the Empire State Building, we have only about 2.5 stories worth of fresh water, a lot of that trapped in ice and away from humanity. Getting a little bit closer to what humans have access to, if you look at the fresh groundwaters of the planet, it turns out that we have the height of a human being relative to the entire height of the Empire State Building. And I've checked these numbers several times, and I really do think they're correct. If you asked how much water is available from the principal source of renewable water on the planet, that is river systems on the Earth, this dwindles down to a penny. And let me be clear, it's not the diameter of the penny, it's the thickness of a penny. And not only that, it's half a penny thick. So it's an extremely restricted resource in relative terms. This is where all of humanity has to live. It lives on this penny, and the penny's not evenly distributed, as we know, because there are wet and dry parts of the Earth, populated and unpopulated parts as well. Now, the point I'm trying to make here is that in relative terms, it is this precious resource. It's relatively rare on planet Earth. And I think to some degree it's also conditioned the way we interact with that resource. And I'm terribly sorry this isn't showing up, but what I'm showing is a series of pictures here of human enterprise having to do with water, whether it's sanitation and access to drinking water, engineered water, food security, industrial activity, et cetera, et cetera. Let me just say that we have a tradition of studying water. The history of the science of hydrology dates back a bit more than 100 years. It's really focused on local scale phenomenon. Our science of water, our perception of water problems, and our management of water problems are very typically organized at the local scale. And I guess the big question is, if we're talking about global water, what do all the countless decisions and management activities of humankind, the countless millions and millions of day-by-day decisions that we all make, what does that embed within the system? Late 2010, we were lucky enough to have a paper come out in Nature, and I'm very proud to have been working with a group from Diversitas and the Global Water System Project to come up with these set of first maps of the threat to this penny, okay, these inland waterways. And what we see is something that's very interesting to us. As you accumulate all of these mismanagements and also good management examples, put them into the global domain. So you're taking local scale information, spatialized, and you're aggregating it to the global scale, what we find are some very interesting patterns. So for example, on the left, we see a view of water system threat for the year 2000, looking at the state of the resource. And what I'm talking about is the state of the resource on which humanity must survive. I'm also talking about the state of the habitat and the water systems and the ecosystems that sustain habitat and aquatic biodiversity. And very oddly, you look at that map and you say, my goodness, why is a place like Europe that has framework directives on water, that has an educated population, that's filled with technology to prevent these problems from happening, that has environmental regulation, why is this happening? And our conclusion is it's a byproduct of economic development. It's a byproduct of those curves that Johan displayed, those many, many curves that are linked to human development. And in the case of water, I would say it's a bit sloppy development with respect to how the water systems are getting hit over the head. Now, on the right is our perception of human water security. So I've been here for a few days. I've taken several showers in my hotel room. Every time I turned the faucet on, there was water. Every time it was clean. I was able to drink water to my heart's content with no problem. It tasted wonderful. It was clean, no problems. That's water security here in Europe. Okay? And therefore, if you have threats from low to high, blue and green are better systems. We've got much better systems here in places like Europe and the United States than we do in places like Africa. So what we do to transform this picture of how we've treated the resource in the ambient world and how we deliver it to humanity has to do with a set of numbers that I really apologize don't show up. I will read them to you. There's an arrow connecting those two worlds, and the arrow is water infrastructure. It's $0.75 trillion a year for water infrastructure to create new water systems, to deliver them to humanity, and also to rehabilitate damaged systems. But taken all together, these local scale impacts accumulate to global syndromes. And I have to say, with all due apology, the integrated water management paradigm, which we are really putting all our eggs in that basket, there's very little evidence, in my view, to support that it's being instituted broadly across planet Earth. So this is, I think, the development imperative. And in fact, what we've uncovered by doing this analysis, by not being frightened of looking at something at a scale in which the data sets were not originally targeted and for which there might have been some bit of professional jeopardy in terms of the review process, we discovered that when you put this all together, the paradigm for the modern water systems of the world is develop, impair the systems, and then when you can, repair the systems. And for rich countries, this certainly is the case. Okay, well, I was also greeted to the Anthropocene by The Economist. And of course, if The Economist says we're in the Anthropocene, one should believe The Economist. But there is the Holocene. And as we just, or as our last discussant talked about, the Holocene was a very special time for human development. And we can argue about when the Holocene, when the Anthropocene began. Was it when the steam engine was invented, or was it during the great acceleration after World War II? We could have debates about that. But if you had a debate with a paleontologist, the paleontologist would not be convinced at all, because the way in which the standard geological nomenclature is changed. You change the name of an epoch based on species changes. And I would say we could also debate the rates at which you see species changes globally. But the graphic here on the right, oh boy, the lettering didn't show up at all, is basically looking at the number of species that reside in different domains, the marine domain, the land domain, and the freshwater domain on a per area basis. And what you find in terms of the described organisms, the freshwater domains are real biodiversity hotspots because they're very, very unique environments. They're fragmented in a sense in terms of how organisms can move around, extremely biorich. In terms of these bars here, for the same domains, and I can't get my, marine, land, and freshwater, these bars show the imperilment of species and the loss of species. And on a per area basis, these rates are orders of magnitude higher than in the land or terrestrial land mass. and the marine biomes at large. And by a paleontological perspective, I think that we can safely say that fresh water is in the Anthropocene, just like that banner says there. And we could debate about whether the rest of the planet is, but certainly it's leading the way into the Anthropocene with these very, very dramatic losses of species. Now, I come from an Earth system science perspective. The next speaker will be my complement speaker in terms of the human dimensions of our work. But I'm very used to looking at a curve like this, which I remember seeing when I was a young kid in college, and it's continued to go up. It's the Mauna Loa curve for carbon dioxide. This is the irrefutable call to arms of the global change community. And I would say that overall, in the last at least 20 years, the global change agenda has really been dominated, really been focused upon the climate change question. And why wouldn't it be? The CO2 is shooting up in the atmosphere, and there's good reason to believe that it's going to continue that way with all sorts of havoc on the climate system. That's true, I don't doubt that. But there are also a bunch of other things happening. And those other things have to do with the direct modifications of water systems that are summarized here by my colleagues Strayer and Dudgeon in a 2010 paper, where we see water withdrawals going up and large dam building going up and inland fishing going up and nitrogen pollution going up and invasive species going up. And this is just a subset of what Johan had shown a few minutes ago. These are all the direct, what you might call insults potentially to the water systems. They're also the impetus for water management. So we're not going to get rid of these trends instantaneously. I'm going to hit the button here, and I'm going to unveil an experiment that my good colleague at City University, New York, Balázs Fekete, has provided to us. And it's looking at the AR5 scenarios of climate change under a variety of different atmospheric forcings. And one of the interesting aspects of this is for runoff over I guess, 150-year time period. That very dramatic curve for carbon dioxide has now been replaced by very noisy curves in terms of the interannual variability produced by the models. And the trend lines seem to have disappeared, or at least the rapid changes seem to have disappeared. And there's an ongoing debate about what's going on here. There's an ongoing politicization about carbon control questions. And with that cacophony on the left, and there's a lot of political noise about this on the left as well, we see these much more deterministic, I would say, trends in things that matter to the water system. And I asked the simple question, what does this really suggest about the factors, at least for the next several decades, that are really going to be calling the shots in the water system? And perhaps more importantly, what are the messages we send to the policymakers? And maybe the message we send is as follows, since we really don't understand how the whole system is put together, but we do know that certain trends are probably going to be with us for a long time to come. How can we handle these? Maybe what we need to do is stage a Hippocratic Oath, as they have for young doctors when they become certified and go out into the real world and practice. Maybe there needs to be a Hippocratic Oath for water. And I went back and I read the Hippocratic Oath, and you find some interesting language there. So if you take the oath, at least the old oath, it was, I swear by Apollo the physician, Acephalus and Hygiena and Panacea, words that I think we know as Earth system scientists, and all the gods and goddesses as my witnesses, all of them, perhaps some are in the room, that according to my ability and judgment, I will keep this oath and this contract, but we better know what we're signing on to. So if you dig into it a little bit, you find some interesting advice that I give my students. Honor thy mentor and his offspring, not just the mentor, but his offspring. My son likes that. Discretion. There's a statement in the old oath about discretion, and if you're from the United States, there are these disclosure laws that you're not supposed to disclose medical histories to third parties, and there's an early version of the so-called HIPAA law that's sitting there thousands of or hundreds of years ago. Then, this is an interesting one. No seduction of women or men during house calls. Says nothing about hospital visits, but certainly in terms of the house calls, you're supposed to behave yourself. And do no harm or injustice. That's probably what we know best. And a variant of that in the modern version of the oath is prevention is certainly preferable to cure. And I think that in terms of our stewardship of the water systems, we have to begin to think along these particular lines. Now, with all of the challenges that we've heard from all the speakers so far, and I would say at precisely the moment we're most concerned about water, I would also say that our level of commitment to really handling the problems can be called into question. I really think it should be. And one of the prima facie pieces of evidence for this is how we look at planet Earth with respect to water. And this time series that you see from 1900 to year 2012, with a vertical axis here, the number of reporting stations, is the archive of the UN-designated repository for runoff information, runoff and stream discharge information being the mainstay of water resource assessment. And you notice a very peculiar thing about that curve. It rises up exponentially from year 1900 to about year 1980, and then it comes crashing down. And what replaced evidently a concept of a global knowledge commons for this information and great level of collaboration among the member states who've put this information into the archive, it comes crashing down after 1980 because of the cost of running these networks and the closure of these networks, in particular as agencies are put under economic strain and they don't have the operation funds to run these things. There are also issues of commercialization of the data sets and intellectual property rights, and these all conspire to bring the curve crashing down. So if you ask me to paint a picture of the world of water in 1980, I could do a better job than I could if you asked me to do so with this data set in the year 2012. Furthermore, if we think that high technology is going to bail us out, and I'm not saying high technology is not valuable in any way, it certainly is, but in terms of the commitments that the space agencies are making, and I show here some results from the National Research Council in the US, a decadal survey of Earth system science missions, you see that looking from 2000 to 2015 or so, or 2010, the commitments to run these sensors are flat and they decline afterwards. And as I understand from looking at newspaper accounts recently, a similar kind of a situation may beset the European Space Agency. Now, if we wanted to do something about this, we can make some calculations that about 2,000 stations will probably give you some pretty good coverage if you used the traditional stream gauging networks. And at $15,000 US per station, that brings it up to $30 million. So I want to put this in a little bit of perspective, but I'm not going to use the Empire State Building this time. But what I will do is I'll zoom in on that number I couldn't show you because of the font coloration. That's $0.75 trillion of investment in water infrastructure and operations. That $30 million is 0.004% of that investment. And to me, it's noise level, and it's amazing that we don't make commitments to collect this information. That's one way to look at it. A far more cynical way to look at it is contained in this set of statistics. It's a fraction of Tiger Woods' annual earnings, and I would say even after his recent stumbles. And according to Forbes, that guy makes, I didn't know this until we looked it up, that the minimum this guy made since 2001 is $58 million. So we could have 4,000 stations or thereabouts if he would learn his lesson and donate some of his proceeds to science. Okay, just by a show of hands, does anyone know what this is? Does anyone know what this thing is? Oh, interesting. This is the first photograph of an extraterrestrial planet, and it's next to its star. And actually, the star is the red dot. It's a gigantic planet that was discovered. And it's called Planet 2M1207b. I kind of like the name Earth for our own planet, but it's the first one outside the solar system. Its discovery was confirmed in 2005, and the snapshot was taken of the new baby in the world of science for us. How did we get to this state of affairs where we can actually see terrestrial-like planets? Well, we throw money at the problem, right? And in this particular case, the observatories on land, in particular the southern hemisphere in South America, and the Hubble spacecraft conspired to the tune of several billions of dollars to come up with this snapshot of this new planet that we see. I guess in the context of what we're talking about in terms of the decline in our own observational networks of water, this, to my mind, is somewhat lamentable. Now, this particular planet shows, as many of the other 87 planets that have been discovered since 2005, it shows a very clear presence of water from the emission spectra. Ironically, that first system was in the constellation of all things called Hydra, which I think is apropos for looking at a water signature that confirmed its existence. But like this particular satellite, all these new planets are now being found routinely. And the search for water is the thing that we're so interested in on planet Earth. The search for water is the search for life. And as the astrobiology and astrophysics community is poised, maybe not in my lifetime, but maybe in the lifetime of some of you or some of your children, poised to make what I would think would be the most profound of any human discovery, that there is water and life somewhere else. We have a planet shown on, oh my gosh, it's not really showing up, I'm sorry. But we have a planet which is shown right here. It's called Earth. And this is our solar system here and some of the planets. These are the new solar system planets, and two of them, they believe right now, could be inhabited by life forms, potentially, because why? There's water there. And so here on Earth, we know there's water, we know there's life, and we seem to be turning a blind eye to it, but we're captivated by the idea of water and life. But we're captivated by that idea 1,200 light years away. And I think that if you sum up the last 2 or 3 slides here, it has a lot to do with how we make decisions about what we're interested in making investments in, decisions about what's important to us, what do we protect. These are issues of values, of culture, of decision-making, and dare I say governance, which will be the topic of our next discussion. So I'm going to be handing the baton over to my co-chair, who will hopefully be able to talk about the global water community being at the cusp of perhaps a new way of thinking about how we govern this very, very important resource. Thank you.